All right, next we'll be joined virtually by Necdet Gürkan, who will be presenting on learning and enforcing a cultural consensus in online communities.
Can you guys hear me now?
Yes.
Yes. Okay. Sorry about that. Okay. Again, hello. Sorry about that. My name is Necdet. I'm a PhD student at Stevens Institute of Technology. Today, I'm going to present our work with Jordan Sucho on learning and enforcing a culture consensus in online communities. So with cognitive science are interested in understanding social interactions. However, these social interactions are complex behavior that are difficult to study in laboratory experiments and draw causality from observing them in the real world because they are not fully observable to us. In past decades, social media platforms and communities on those platforms has been increasing tremendously. And it provides unique opportunity for cognitive scientists to understand complex behaviors because these interactions are fully observable on these platforms. And each online community has its own set of rules and expected behaviors from the members to serve their purposes. For example, Reddit is a social media platform that provides a virtual environment for many different online communities. Let's consider cryptocurrency online community that is fully dedicated to discussing and sharing information on crypto-related topics. So it's very important for members to understand the community purposes and the norms support these purposes. And so online communities rely on their members to understand and follow community norms, which they learn by observing others and the consequences of their behaviors and receiving feedback via moderation. So here, we are interested in understanding how norms in online communities are learned and enforced. What is an online community? Online community is a virtual space for people who share similar interests in a particular topic. Since each online community serves different purposes, they have different set of rules. And these rules are supported by the community norms, and often these norms become their rules. And norms determine what actions are acceptable and unacceptable. And it has been shown that communities benefit from building strong norms that serve their purposes. And one of the key elements to building and preserving strong norms in online communities is moderation. There are mainly two types of moderation mechanisms that are found in online communities. One is that centralized moderation, and centralized moderation is done by a group of leaders in online communities who understand the community norms and their function. And they are called moderators. And when moderators see an action that is misaligned with the community objectives, they flag these actions by commenting, banning, or giving warnings. Also, we have this centralized moderation mechanism that are performed by the community members. And the community members can encourage or discourage certain behaviors by commenting, liking, or disliking the action. And this mechanism of moderation becomes difficult when the community norms are intersubjective, in which each community member needs to align their subjective behaviors to group behaviors. So how are we going to estimate the community norms and study these estimated community norms? And the norms are not directly observable, so we need to infer them from observable behavior using some mathematical model. And the culture consensus theory is a standard mathematical framework to study norms. And culture consensus theory is developed to create an answer key when we don't have it. In other words, when we need to derive the answer key from observed answer. So responsive answer determine the answer key. And culture consensus theory is used to estimate cultural held beliefs and individuals' competence, which is each group member's understanding of those cultural beliefs. And culture consensus theory is widely used in anthropology, mental health, cognitive evaluation, and organizational culture. However, culture consensus theory is not well suited to study online communities because online communities persist over time and they learn within themselves. And there are two types of learning exist in online communities. One is learning from observation. Second, learning from centralized moderation. And third, learning from decentralized moderation. So we extended culture consensus theory to include learning from experience and centralized and decentralized moderation. So before I go into our modeling framework, I'm going to talk about online community we study in this paper. Here we studied True Rate Me community, which is dedicated providing what they believe are objective facial aesthetic scores for people who are interested in getting feedback about their facial aesthetics from the community. And in this community, the score scales between 1 and 10, the 1 being the lowest and 10 being the highest score. And also this community has a set of guidelines for their members on how to rate face beauty. And the reason we chose this community to build our model upon is that this community strongly enforces its social norms. And those norms are quantitative, which makes it easier to model them. And there are 3 ways you can participate in this community. 1, you can share your photo. Second, you can provide the rating that's aligned with the community norms. The third, you can give us some statement that how a person can improve their facial aesthetics. And the other behaviors are unacceptable and you get banned immediately. So we use a push shift and Reddit API to collect our data. In total, we have about 173,000 top level comments with ratings. And we created this tensor as an input to our model. And this tensor includes user ratings for face image, users nth rating in the community, score value for comment, and moderation the comment. And the score here is that the likes minus dislikes, and the moderators have encoded as 0 is unmoderated, 1 is for underrating warnings, and 2 is for overrating comments. So in our extended CCT model, as I mentioned, we included learning from experience. In traditional cultural consensus theory, competence is estimated from the agreement metrics. But in our model, we assume competence improves as a function of the number of given participation in a process of exponential saturation. So respondents begin participating in this community with some initial competence, and the learning rate determines how fast one's initial competence reach the community asymptotic competence. And asymptotic competence represents the best one can get in this community. Another extension of CCT we have here is that decentralized moderation. And in online communities, the community can react to action by liking or disliking the post. And in Reddit, as I mentioned, we just have we don't have the access to number of likes and dislikes. We just have the likes minus dislikes. So to extract the proportion of votes, we use the absolute distance between the rating and the consensus item to drive the rating score. And then another innovation in our model is centralized moderation. The centralized moderation model using vigilance, probability, and moderator sensitivity. The vigilance represents moderators are not perfect, and they notice misaligned responses with a probability of less than 1. And also moderators have limited sensitivity and error with respect to the consensus. And we use the vigilance probability and the moderator sensitivity as an input the sigmoidal link function to cast warnings, which is overrating or underrating. I'm not going into detail to every single parameterization in our model. However, I will just talk about the big picture. So we have three main components in our hierarchical model. The one is that individual level parameters, which includes level of knowledge, competency, and the user's shift and scaling bias. And for centralized moderation, we have moderators vigilance and sensitivity and directional moderation. And for decentralized moderation, we have the community sensitivity. So after we input the data in our model, we were able to observe some of the unobserved latent variables. And we found that the quick perception adaptation after the user's first rating in the community to recalibrate their responses to the group social norm. Here in the figure 1, we see the ratings as function of consensus, and each black dot represents a rating, and X equal Y line represent the perfect recalibration. And the T represents the user's end rating. For example, T1 is the users who have the user's first rating, T equals 5 users fifth rating, and so on. And here we actually observe two kinds of learning. First, there's individual learning, and also there's a competence-dependent tenure in this community. In the low competent users tend to drop out, and which actually supports the group perceptual learning. And we found that the initial competence is found to be predictor of involvement in the community. In figure 2, we see the log number of rating as a function of initial competence. It actually supports the idea of the lurkers in this community. The lurkers are who spend some time in the community before they start participating. So they observe the community for a certain amount of time, and they understand the community norms and their purposes. And if it fits with their objectives, they start participating. And also we found that the experience in rating items is an important indicator for group perceptual learning. In figure 3, we see root mean square error is function of experience, and we can see once the experience is increased, the root mean square error decrease. And for decentralized moderation, we found that even though the rating is very off from the community norms, there is the 17% chance that the moderators will moderate the rating. In figure 4, in the left subplot, we see probability of sign action as function of distance. Distance here is defined as consensus minus rating. And so on the x-axis, the negative values is for overrating, and the positive side of the x-axis is for underrating. And upper and lower asymptotes corresponds to best fit vigilance parameter. And on the right subplot, we see ratings as a function of consensus. And each gray dot represents the unmoderated ratings, and the black dots represents overrating casting, and the red dots represents moderators underrating warnings. And we see is that even though moderators often do a great job identifying ratings that are misaligned with the community norms, we see that moderators reflect some of the ratings that are aligned with the community norms, and which may affect the health of the community. And also we found that the community members show high sensitivity when providing feedback on other members' rating. In figure 5, we see upward proportion as function of distance. Distance here is absolute distance. Even though you can see here is that even though you are off 0.05 in this community, there is a huge drop. And it supports this community has a strong norms, and the members know these strong norms, and they react to the comments according to that. So here we study a particular online community that provides a unique opportunity to leverage psychophysical methods to understand your subjective culture phenomena because of how amenable this community norms is to quantitative characterization. And we leverage this observed data in our hierarchical model to determine item consensus, moderation errors, and user confidence more precisely. And future work can extend our computational model to infer each moderator's competence along with their biases in support of providing more transparent mechanism for promoting the health of online and other communities. And thank you very much. What questions do you have?
Any questions, virtual or in person, please? All right, thank you.
Thank you.